Hi folks, welcome back to Physics with Captain Rod. I'm making this video to help you folks out with a couple of problems in your Unit 2 homework number 1. So we're going to start with a discussion of number 27, and it says a 3 kilogram block starts from rest at the top of a hill inclined 29.5 degrees, slides 2 meters down the hill in 1.4 seconds. Now some of these numbers are red, which means yours are going to be different, all right? But the big thing are given. There's a mass given, I'll put G here for given. There's an angle given, I'm going to put theta. There's a length given down the incline, and a delta t. These are all numbers that are given. So the first thing you want to do with all of these problems, draw a good picture. You know, maybe something like this. Take the time to set these up well, and it'll go a long ways towards this. We know that this thing's accelerating, so remember the motion diagram here. Here's a way to show that in our picture. You can even put the velocity vectors getting larger. Now, at this point in the class, there's really two types of physics we've talked about, right? Motion, right, and Newton's laws. I'll just put, I like to put Newton 2 for Newton's second law, basically, and they're two distinctly different things, okay? A lot of this data given, let's see, a length, a time, an acceleration, that's all stuff that's about the motion. So I'd probably start this like every problem that we start studying the motion, start with a velocity graph. Now, I am not going to, oh, I'm sorry, the acceleration is not given. This is not given here, but that's okay. Start with a velocity graph at t equals 0. It starts from rest. I'm not going to do the rest of this, but they tell you a delta t, and I guess we don't know a v final. So that'll be an unknown in your picture. But go ahead and put it on the graph. Then make a constant acceleration assumption that has a very specific consequence on your graph and the shape. And then use area. Right, and that gives your displacement, your delta x. In this picture now, delta x is like this way, and that's going to be this. You're going to be able to solve for t. After you use area here to write an equation, you're going to be able to get the time. After you do that, then the acceleration, right? Ask yourself, how does that relate to this graph? Or write down, what is acceleration equal to? That should get you the acceleration. So now, at this point in the problem, you should have a known acceleration. Now we'll start talking about this, the force analysis. So I'll just use this picture right here. Draw yourself a free body. Right? You should have an mg, a gravitational force in there. You should have a normal force. And remember, normals are always perpendicular to the surface in contact. Look at the surface. This is the surface in contact, like this. There's a frictional force, as kind of stated in the problem. Now friction is going to be parallel to this surface and opposes the motion. And then you're going to want to write an equation, right, from that free body. Sum of all forces equals ma. And remember, Captain Rod's rules of thumb, carrots here. One of them is identify the acceleration direction, call that positive. This thing is accelerating this way. So you're going to want to write a force equation. There will be a component of this in this direction. And the frictional force will also show up in that equation. From this equation, you should be able to get a frictional force. You should be able to get a number out of it looking at this, right? Then we're going to write another equation, sum of all forces in this direction. Now look at our picture this way. The block's not accelerating that way. So when you sum forces in that direction, that equation will have an mg in it, a component of the mg. I'll put an mgc here for component, all right? It will have the normal force, and that will be it. Out of that, you should be able to get the normal force, and you should be able to get a number out of it. And then to get the coefficient of friction, right? So sliding friction is equal to the coefficient of friction times the normal. So when you get that number, that will go here. This will go here. Out will come your frictional coefficient. So that should get you through all of it. Now, when it says A, B, C, D, by the way, the first thing you're going to probably answer is D. If I go back to the picture here, because the very first thing you're going to get out of this is me a moment here. Oh, I guess I have to go back to this a little bit too, by the way. I'm sorry. I think I misstated this. The delta t is given. You're going to get the v final out of that, going back to the beginning. I don't think I'm going to redo the video. Apologize for that, but I'm just going to leave this as is. But when I go back to that, you're going to draw this graph. This point over here is going to be t, which is known, v final, which is unknown. When you use your area to write an equation, you're going to get v final. But then you can use the slope to get the acceleration. And that's going to be your answer to D there. So sorry about the order of that. Anyway, that's enough on that problem. After you get D, then you can do A, B, C, just as stated. All right, let's chat about 28. I'm just going to get rid of all of this. Okay, so let's see. It says something about a bucket of water. So I would start like all of this, a picture of the bucket of water here. It's got some water in it, probably. There, that's good enough for a bucket of water. It's probably got a handle. Let's see, it's raised from a well by a rope. I'm going to put the rope here, but going off to who knows where. It says it's accelerating this way. So what you're going to do is draw a free body of the bucket. There should only be two forces on that free body. You got the gravitational force and a rope in contact. And then write a Newton's second law equation. Sum of all forces equals ma. And remember, Captain Rod's rules of thumb. Identify the acceleration direction, call that positive. All right, you should be able to easily write a force equation and just solve for the unknown force. That's about all there is to that one. So I guess I'll call this video done.